here and group on each bench, basically. And then I'm going to start talking a little bit as we migrate.
Hey guys, you want to go find the bin?
So everybody, just want to welcome you again to Semper Sky's practice for water monitoring. We have a contract with the Virginia Department of Environmental Quality, and the County of Stafford has been kind enough to let us practice some of the things that we need to do to look good while we're doing our actual contract. So again, this is not the actual contracted thing that we're doing here. So anything that we do with any water here is all simulated. So we're not going to give you, like an opportunity to go touch raw water from the reservoir, but we are going to give you an opportunity to understand, thanks to Mr. Rob Turner here, how you get the clean water that you do in Stafford County. I got a chance to look at the facilities on Friday, and I was extremely impressed, and I'm hoping that you all get a chance to understand like what they go through. So we're going to give you a little mini way to look at that for yourself. But the other reason that we're here is for a sense of community on Dr. Martin Luther King Jr.'s holiday. His birthday is January 15th. We recognize it on the Monday closest to his birthday. And what this is about is diversity. Can someone tell me what they think diversity is? Anybody? Be one word, anything you want to say. A melting pot? Okay. I didn't hear you.
Oh, I was going to say heaven.
Heaven? Okay. All right. Anybody else?
Conclusion.
Conclusion. When I think of diversity, I think about differences, right? And over history, we've seen that diversity and the way we look at it has changed. Really, it wasn't until about the 1950s or so that the term diversity started really being said in the English language more often. So before then, I'm going to go all the way back to the Bible times. Hey, I'm Christian. I don't hold you all to that, but I will speak on it. So in the Bible, there's a verse that says that God doesn't look at man the same way that man does. God looks at men for their character. All right. And then in the 1800s, you have Abraham Lincoln, who says, the 4-score speech, the Gettysburg Address, right? He says all men are created equal. And then you go to the 1950s, 1960s, you see Dr. Martin Luther King Jr., and he said that he had a dream that one day his children would be looked at not for the color of their skin, but for their character. And what I say to you today is we can use our diversity, our differences, to be more accurate in our predictions and our problem solving when it comes to science, technology, engineering, and math. I look at our group here and I see how diverse we all are. And there's actually a mathematical formula for diversity, or for crowd error is what it's called. And it's basically saying that the more diverse your crowd is, the more accurate your answer is going to be when you're predicting. When you're problem solving, sometimes diversity can be confusing. When you have people who speak different languages, etc. One such example is a Mars shuttle orbit team that went up in 1998. They were giving inputs back to the ground station in the English system of measure. Those were being received in newtons, which is under the metric system. And as a result, instead of orbiting at 150,000 kilometers, they orbited at 60,000 kilometers. Gravity took over and they crashed. So we have to learn how to work together when we are diverse. It takes good leadership, and it takes everybody having a good attitude toward diversity. So with all that being said, I'm hoping that you all are ready to make the impossible look routine. All right, I'm going to give you one quick example of diversity and how we want to look at it today. And we're talking about diversity of thought, okay? Not necessarily how you look, but how you think. All right, let's say we have 3 people. Hey, somebody give me a name that starts with A. Adam?
Abraham.
Okay, Abraham. All right. I'll do Abraham. How about one with the letter B? Did I hear Brad? Okay. All right, how about one with the letter C, and can it be a lady's name this time?
Cecilia.
Cecilia. All right. So we want Courtney?
Callie.
All right. Okay. So Abraham, Brad, and Courtney all take a 10-question test, right? And Abraham and Brad get 8 out of 10. Courtney gets 7 out of 10 correct. Let's say we are at school and we have to choose 2 of the 3 who are gonna move on and do something or get recognized or do some project. Which 2 do we pick? Anybody? You want the ones who got 8 out of 10? Or do you want?
I want one of them. They got 8 out of 10.
Okay. Why do you want just one of them? Okay. What if I told you that, what was it, Anthony? What is the first one? Abraham and Brad got questions 1 through 8 correct, but Courtney got questions 4 through 10 correct. Does that change the way you would pick? Right. Well, all 10 of these questions are made to figure out how well these folks can solve problems. Right? So, do you want to diversify and have 2 people who can solve 8 out of the 10 problems? Or do you want to have one who can solve the first 8 and one who can solve the last 2 that you need? So those are the things I asked you to think about. And so when we are working with you today, we're going to show you just a little tiny insight into things like water treatment. And this is all part of science, technology, engineering, and math. STEM, for short. But I want you to use your ways that you think and apply them as you go on and maintain an interest in STEM. And one day you can make STEM better. That might even be today. So let's find out. So I have my team here. I've got Miss Forrest Centinella. Rob was kind enough to let me take this sample on Friday. We are not using this water in any way, shape, or form during this. I want to be very clear on that. This water is untreated, okay? But I wanted you to see that these are the types of things that we can do to test water quality. All right. How many of you all are thirsty right now? Anybody thirsty?
I don't know. You said water, and I'm good right now.
Not that water.
Yeah, I'm good right now.
Okay. Hey, I'll drink some Stafford County water. I'm down, but after it's been treated, of course. Yeah. What do I get next? This?
Funnel right here.
Can y'all see the funnel here? All right. What do we do next? Put the funnel here.
Yes, put your funnel into your basin.
Okay. What's next?
Slow down.
Yeah.
All right. Make sure you put it somewhere where it's slightly stable. We know it's kind of windy.
Oh no, you had it right. It's like this. Turn that. Put that inside of it. There you go.
There you go. Right there. Wait for the next thing. There you go. Genius.
We don't have any up here. We can see that.
This one?
Oh, crap.
Oh, we had it.
That's what he was doing.
Let's put it in here.
Oh, okay.
Okay.
Well, make sure you do a really good job. Okay, the filter.
We have a double layer. Should it be double?
Yeah, double is okay. Single is good too.
Sand and push down our.
I don't want to drink sand.
But this is important. This is part of the filter.
We got some sand for you right here. Come on over. Send one on over, Red Rover.
So you're gonna get some sand.
You want some sand?
We need the sand.
Bring your filter over.
We need the sand.
Yeah, bring your filter over.
One and a half.
Go watch the sand, Joel. Don't touch it, just look.
We just like to do that bigger example.
Go back here. Go back.
All right, so we got our sand in here now. So I guess is it ready to drink now? I don't even see the water in there.
We're not there yet. We've got to go to our charcoal.
Charcoal?
Charcoal.
Put charcoal in water?
This is not your grilling charcoal.
This stuff says anthracite.
It's also called anthracite. So next we're going to put our anthracite over our sand.
We're putting charcoal in water, everybody. I don't know. We're gonna have to work this out. The Brita filter is using charcoal,
The Brita filter.
so I don't even have to go to the store anymore. I can just go to the grill for when I want to grill. I just open the Brita filter. Okay.
So come on up and get your anthracite.
Bring up your.
You wanna go take it up there, baby?
I have the charcoal one.
So what's next? We ready to drink this or what?
We're not ready. So next we're going to put gravel on top of everything.
Gravel.
Gravel.
So we're putting rocks in our water?
The gravel acts as the first
Are we
seed.
making stone soup now?
No, we're not making stone soup.
Very well.
Please bring your filter up for your gravel.
How much?
Just enough to cover the top.
Let me give you a little bit more. Strong blend. All right. So now we've got, what is it? Sandy, rocky, coaly. What else was in there? Coffee filtery.
Yes.
And Brita, what is it? What is that little wire pad? All that stuff's in our water?
Yes, to
Okay.
filter it.
Dude.
So next, we're going to take our simulated raw water.
Okay. Looks like you all have water, right?
Everybody should have some water.
Right next to you there, Miles. And we just pour it in like this?
You just pour it in.
Why can't I just drink this raw water?
Because we have to treat it first.
Oh. Treat it to lunch?
Treat it to
I'm
lunch.
hungry.
There you go.
Yeah, mix that up.
Ours actually came out pretty good.
Alright, well, it looked a little dirty to me. Do something else before we just drink that water?
Yes.
What should we do? Anybody know? Ladies and gentlemen, what do we do? What do we do once this water finishes being filtered? What do we do? I wouldn't mind doing it again.
How about we test it?
Boil it. We gotta boil it, right? So that's why we're not gonna drink this water, right? Because we haven't boiled it, right? Not for other reasons.
Because what else could we see could possibly make us sick that we can't see?
Like bacteria.
Organisms,
Bacteria.
E. coli. So the following step would be to boil it and test the water quality. Alright. So in the future we're looking at doing another clinic like this to help teach water quality. One of the methods for evaluating water quality is testing turbidity. Turbidity is to test the amount of solids, suspended solids in the water. So this Secchi disc was originally invented by a Jesuit priest who left Rome and actually went to the University of Georgetown in Washington, D.C. He made friends with the United States Naval Observatory and then turned his studies to the aquatic and invented the Secchi disc. This is a very simple device that is still currently used, has not been replaced by chemicals, lasers, anything in modern day because it is still accurate and it is one of the most cost-effective ways for citizen water monitoring quality to be done. And so we're looking at helping the community learn how to make these. So all it is a weighted disc that is colored black and white, just like this, attached to a string which has intervals right here at 10 centimeters. As we spoke earlier, we talked about English measurement versus metric. And Juice gave a great example on why we're using the metric. Does anyone remember that example? That,
They used English, but it was converted to metric and they converted it to
correct.
All right.
So what we'll do is we'll take this disc and we'll go to the end of a dock, or we'll be on a boat, and we will lower it, and we'll keep lowering it until suddenly we can no longer see the disc anymore. And then we'll go to the water surface and then measure the length from there. And that will give us a very accurate, inexpensive water quality testing. Now, right here you can see that is roughly,
I got it back, sorry. My bad.
that is roughly 84 centimeters.
So one of the things that we want to pay attention to is our trends, right? So if 1 month it's 84 centimeters, then all of a sudden it becomes 70 centimeters a month later. Something's going on with the clarity in our water, and we need to figure out what's going on with our filters. So in other words, maybe one of these processes that we have going on is having some trouble, and we need to go investigate. So,
Are there any questions about the Sechi disc?
awesome. We have Mr. Rob Turner here, and with Stafford County, in charge of Smith Lake, and he's going to talk a little bit about how this little mini thing is translated into a much more complex and better working system.
We take the water out of the Smith Lake Reservoir, which is behind the dam here. It's a 2.5 billion gallon reservoir. And on a daily basis during the winter months, we're averaging 7.5 to 8 million gallons per day. That's about 6,000 gallons a minute. So you see, we're making a little bit more water faster than that. But like I say, behind you in this big building is essentially the same kind of setup as this, just on an industrial level. Like I said, we take the water out of the Smith Lake, and we bring it up through the raw water pumps on the backside of the plant. It goes through a rapid mixer, which mixes in the chemicals to allow the sediment and makes the flock come out. It goes through some clarifiers. All of the mud settles out because you want to try to take as much sediment out of the water as you possibly can with chemicals first, and then you let the filters do the rest of the work. So, but that's pretty much the same setup as what we have inside the building, just on a lot larger scale. So, and like I said, right now the flow rate we're doing is about 6,000 gallons a minute. So.